Section 5.2, Exponents to Exponents. X to the n raised to the m power is multiplication. It's x to the n times n, so you're distributing the exponents. As an example, if you have x to the fourth raised to the second, it becomes x to the 4 times 2, or x to the 8th. If you have a number, 2 to the third raised to the second, that becomes 2 to the 3 times 2, which is 2 to the 6th, and 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2, which is 64. If you have division and an exponent, x to the m divided by y to the m gets distributed over the bases. As an example, if you have minus 3x squared divided by 5 to the third, 3 exponent gets distributed on all exponents. So 3 has a 1 as an exponent, 5 has a 1, so it becomes minus 3 to the third. X is 3 times 2, so x to the 6th, and again 5, it becomes 5 to the third. So minus 3 to the third is minus 3 times minus 3 times a minus 3, which is a minus 27. So minus 27 x to the 6th, and 5 to the third is 5 times 5 times 5, which is 125. So 5 times 5 times 5, that gives you 125. If you have 2 divided by minus 2 raised to the third power, you can do the division first. 2 divided by minus 2 is a minus 1. Minus 1 to the third power is a minus 1. So that would be minus 1 times minus 1 times minus 1. That's still a minus 1. Parentheses, minus 2x to the third raised to the second power. Again, the 2 is distributed as the exponent over all exponents, so it becomes minus 2 to the second, x to the 3 times 2. So minus 2 to the second is minus 2 times minus 2, which is a 4. X to the 3 times 2 is x to the 6th. A to the 4th over b to the 3rd raised to the minus 1. Here, the bases are not the same, so you cannot divide these out, but you can distribute the negative 1 to the exponents. So this becomes a to the minus 4, b to the minus 3. But since these are negative exponents, and when I have 2 negative exponents, I can switch the positions. A negative exponent in the numerator means it's a positive exponent in the denominator, so the a to the minus 4 in the numerator becomes a to the plus 4 in the denominator. B to the minus 3 in the denominator becomes b to the plus 3 in the numerator. So the final answer on this is b to the 3rd divided by a to the 4th. And again, as a review, anything to the 0 power is 1. Scientific notation. In general, the format for scientific notation is a times any number times 10 to the n. If you have large numbers greater than 1, you have a positive exponent. If you have numbers between 0 and 1, you have a negative exponent. As an example, if I have 6,320,000, I basically need to move the decimal so it's in between the first 2 digits. Because this number is bigger than 1 originally, I will have a positive exponent on my 10-part number. I had to move the decimal 6 places, so that becomes the 6 on the exponent. So 6,320,000 is really 6.32 times 10 to the minus 6. 543.26. Here the decimal is already in the middle, but it still has to be in between the first 2 digits. So I have to move the decimal 2 places to get it over there. So the new number is 5.4326. Notice I put the decimal in the correct position, and because I moved it 2 places, it's a 10 to the positive 2. The reason it's a positive 2 is because my original number was larger than 1. It's 543. When I have a decimal number such as this, 0.000593, this number is between 0 and 1. I still have to get the decimal over in between the first 2 digits. That requires me to move it 4 places. So the new number in scientific notation is 5.93 times 10 to the minus 4. It's a minus 4. The 4 represents the places. It's a minus 4 because the original number is a decimal number between 0 and 1. If you have the number already in scientific notation, such as this, 2.32 times 10 to the 6th, the 6th, I have to move the decimal 6 places. Because it's a positive 6, I want to keep the number large, so I want to move it to the right. So when I move it over 6 places, I have to add some zeros. So 2.32 times 10 to the 6th, after I move it 6 places, is 2,320,000. 1.63 times 10 to the minus 4, because I have a minus 4, the decimal will move to the left, and I will keep the number as a small decimal number, so I move the decimal 4 places, keeping the number small. So when I move it over 4 places, again I have to add some zeros before the 1, so it becomes 0.000163 in regular notation. When you're multiplying scientific notation numbers, you multiply the a parts. In this case, the a part is the 4.6 and the 3.9. So I multiply 4.6 times 3.9 and I get 17.94. I will add my exponents. So 3 plus 5 makes 10 to the 8th. So the answer becomes 17.94 times 10 to the 8th. The reason I'm moving the decimal over is because the decimal always has to be in between the first 2 digits. So if I move it over 1 place and I actually make the number smaller, meaning I was at a number 17, but when I move it over 1 place, I'm at a 1.7, I have to add 1 to the exponent. So when I make the number smaller, I add 1 to the exponent, and it becomes 1.794 times 10 to the 9th. That's the correct answer. Even though 17.94 times 10 to the 8th is the correct answer, it's not in scientific notation. Scientific notation has to have one single decimal. The decimal point has to be in between the 2 first digits. Division. You divide the a parts and subtract the exponents. So for this particular problem, 5.4 times 10 to the minus 2 divided by 5.2 times 10 to the minus 7. You take 5.4 divided by 5.2, that gives you 1.038. The 10 part becomes 2 minus a minus 7, which is minus 2 plus 7, so it becomes 10 to the 5th. Then if I want to take that number and expand it out to a regular number, 10 to the 5th means my number is going to get larger because it's a positive 5, and the 5 means I have to move it 5 places. So the decimal is after the 1, so when I move it 5 places and I add the number of zeros to be able to move it 5 places, the number turns into 103,800.